What is total differential? Total differential. Is it visible?
Yes, sir.
Yes,
Yes,
sir.
sir.
So remember, we will discuss one is total differential and other one is total differentiation. Two will be different. Okay. So remember the term differential here. Okay. Total differential. Total differential. If, what is that you write? If z equal to function of xy, if z equal to f of xy is a function of x and y, if z equal to f of xy is a function of x and y, okay, then the total differential of z, then the total differential of z denoted by dz. So only dz is there means you understand that that is a total differential. That is total differential. So the if z is a function of x and y, where x and y are independent variables, z is the dependent variable, then the total differential of the dependent variable z is denoted by dz. Is denoted by dz. Is denoted by dz and defined as dz is equal to dz equal to, since z is a function of x and y, so we will take the partial derivative of z with respect to x and we will multiply the differential dx. Remember only dy by dx. What is this? Can you tell me? What is this? Dy by dx. What do you understand from there?
Slope of the curve.
Derivative of y with respect to x.
So derivative of y with respect to x. But if I say only dy, what is the meaning of that?
Change of y.
No, it is differential. It is differential. The term coming from derivative is differential. So this is part of a derivative. So it is called differential. Okay. So dz, z is function of xy. Okay, where x and y are independent variable, then the total differential of z is equal to partial derivative of z with respect to x into dx plus partial derivative of z with respect to y into, okay, so this is called total differential of a function z equal to f of xy. Okay. Now similarly, if z equal to f of x1, x2, and so on, so xn, what does it mean? What does it mean? What is the meaning of z equal to f of x1, x2, xn? What is the meaning of this?
It depends upon a number of variables.
So z is a function of x1, x2, and so on, so xn, n number of variables. So how many independent variables are there?
N.
Sir.
X1. So anybody is recording this one, or shall I record?
So you can record.
So you should
You should
record.
record.
But somebody is already recording. Okay. So similarly, if we take whenever it was two variables were there, we were writing the total differential for z as dou z by dou x into dx plus dou z by dou y into dy. Now, if z is function of n variables, z is function of n variables, then what will be the total differential? Then the total differential then the total differential is given by, how can we give it? How can we give it? Can you tell me what will be your dz? What will be your dz? Are you getting my point or not?
Dou z by dou x1 dx1 plus
We are having two variables. We are writing the total differential as dou z by dou x into dx, dou z by dou y into dy. But here we are having n variables. So how can we write the total differential? Tell me. Yeah. Please tell me.
dz by dx.
Dou z by dou x1 into dx1
Dou z by dou x1 because x1 is a variable. Okay. Into dx1
dx1 plus dou z by dx dou
dou z
x2
x2 into
into dx2
and then so and so. What
etc.
will be the answer?
Dou z by dou xn into
Dou
dou
z by dou xn into dx
dxn.
into dxn. So this is the case of n variable. This is the case of n variable. Now everybody got it?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Everybody got it, no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Number of independent variable may be n. Okay. So the total differential will be nothing but sum of these terms. Dou z by dou x1 into dx1 2 into dx2 plus dou z by dou xn into dxn. Okay. So this is the total differential for n variables. Okay. The function which is depending on n variables. Okay, this is the total differential for the function z. Okay, so now let me change this differential into differentiation, total differentiation. Then how can we define it? Only differential means we will have like this. Okay, then what will be the total differentiation? You remember differentiation means derivatives. Differentiation